Hey guys, welcome to the Raptors, a digital platform of the RAPT Excellent Tutorials. The CBSE board exam is scheduled for 9th of April for mathematics, and here in this series we are going to discuss all the concept briefly, and then we'll also do very important questions. So stay tuned guys. So we continue with relations. So relation is a mapping or connection. It is any connection between the elements of two sets. For example, let us consider two sets A, B. Here one has A1, B1. Let us take A1, A2, A3, A4, B1, B2, B3, B4, B5. A1 is connected to B1, A2 is connected to B3, like this. So the first set is called domain. It is also called pre-image, whereas this set is called image. This set is also known as codomain. So the codomain elements are B1, B2, B3, B4, B5, whereas range elements are the elements which are actually getting mapped. So it will be B1, B2, B3, B5. You clearly see that range is kind of subset of codomain. So you can say that range is subset of codomain. Now the domain elements here are A1, A2, A3, A4. Now the relation elements will be A1 getting mapped to B1, A1 getting mapped to B2, A2 mapping to B3, A3 mapping to B3, A4 mapping to B5. These are ordered pairs. The first element must belong to the first set, and then second belongs to the second set. The first should belong to domain, while second should belong to codomain. You can't flip. You can't casually flip. First should belong to the first set, second should belong to the second set. Now, this is basics of relations. Now we'll do different kinds of relation. What are different kinds of relations? The first is reflexive. If A comma A belongs to R, that is same element is getting mapped to itself, then the R will be called reflexive. Symmetric. If A comma B belongs to R and then B comma A also belongs to R, then R is called symmetric. Third, transitive. If A comma B belongs to R and B comma C also belongs to R, then if A comma C belongs to R, R is called transitive. So in transitiveness, suppose A set B set and C set are there. A, B, C. A is connected to B, B is connected to C. Then if A is also connected to C, then it is transitive. A is related to B, B is related to C, and A is also related to C, then it is transitive. Now, the fourth kind of function is equivalence. If R is reflexive, symmetric, as well as transitive, R is called equivalence relation. So for a function to be equivalent, it should be reflexive, symmetric, as well as transitive. So these things we should keep in mind with respect to relations. I have taken a very simple problem on relations which will illustrate you how to solve problems based on relations. So let us see this problem. The problem says let L be the set of all lines in xy plane. So in an xy plane, which is, you can assume this sheet to be xy plane, there is all set of lines, intersecting, non-intersecting, every line, and R be the relation defined as L1 L2 such that L1 is parallel to L2. So this is relation that we are, out of all the lines, we are taking only those lines which are parallel to each other. Now we have to show that R is an equivalence relation. That means we have to show that R is reflexive, symmetric, as well as transitive. Apart from that, we'll also have to find out the lines related to the line, this line. So we need to find all such lines which are parallel to this simple line. Now let us solve this. So we are going to solve for reflexive first. So what is reflexive? I'll draw lines first. L1, L2, L3. For reflexivity, the line should be parallel to itself. Now you see, L1 comma L1 must belong to R. That means L1 comma L1 should be parallel to itself. A line is always parallel to itself. So L1 comma L1 must be there. L1 comma L1, L2 comma L2, dot dot dot. All the other lines Ln comma Ln must be in relation R. Must be there. So the relation is reflexive, as a line is always parallel to itself. Now we come to symmetric. Let it be equation 1. So if line 1 is parallel to line 2, this implies that line 2 will also be parallel to line 1. That is very simple logic. If line 1 is parallel to line 2, line 2 is also parallel to line 1. That means if L1 comma L2 belongs to R, then we can say L2 comma L1 also belongs to R. Hence we can say R is symmetric, because we satisfy this property of symmetricity. Now we come to transitivity, like transitive. If L1 is parallel to L2 and L2 is parallel to L3, then L1 will be parallel to L3. So since if L1 is parallel to L2, L2 is parallel to L3, and that this implies that L1 is parallel to L3. So if L1 comma L2 belongs to R and L2 comma L3 also belongs to R, then L1 comma L3 should belong to R. Hence, R is transitive. This is third point. Now, from equation 1, 2, and 3, we can say that R is equivalence relation, is an equivalence relation. So, through this problem, I try to illustrate how to solve a problem based uh, on relations. So guys, in next video we'll be doing functions, and if you like the content, please like and subscribe. We are now on functions. So we started with relations and functions, we are done with relations, now we are on functions. So what is a function? Function is a spatial relation. It is also kind of relation, but it is spatial with some restriction, that all the elements of the domain, which is also known as preimage, should have a unique image in codomain. So that is the only restriction. All of them should be mapped, and all of them should have just one unique image, single image. That's it. Now you see, x1 is mapped to y1, x2 is also mapped to y2, x3 is mapped to y3, x4 y6, x5 y6. There is no such restriction for the elements of codomain. So you see, we have this set is codomain. Now you see, there is no such restriction. Y1 has got two pre-images, x1 and x2. There is no such restriction. The only restrictions which are there here on function is that the elements of domain should be mapped, and all of them should have just unique image. Now let us take another, like other examples. x1 is mapped to y1, x1 is mapped to y2. Since x1, the domain element, is having two images, that is not allowed, so it is not a function. Now here you see, x1 is mapped to y1, x2 mapped y1, and x2 mapped to y2, x3 is also mapped to y2. It is perfectly a function, not an issue. Here, all the elements of domain are mapped to y1, a single element, not a problem. It is also a function. It is generally called a many-one function. This is also many-one. If there is mapping to a single element in codomain by two or more than two elements of domain, that is many-one function. Now, these are the basic definitions. Now we come to the types of function. So, in your CBS exam, there are two types of functions which are there in your exam. Rather, three. Is first is 1-1, which is also known as injective type. Other is onto, which is surjective type, and third is 1-1 and onto, that which satisfies both the condition. Now, what is 1-1 function? What is injective function? If each element of x1 is having just one image, and this image is just mapped to just one elements in domain. That is, it should not be many one type. It shouldn't be like this. Should not be like this. One element mapped to another, to one in codomain. That's it. There should not be any other mapping. So this type of mapping is known as 1-1 or injective. Coming to the algebraic definition, if f of x1 is equal to f of x2, then x1 should equal to f x2. This is definition of algebraic definition of 1-1 function. The other function is onto, which is surjective. It only says that all the elements of codomain must have a pre-image. That means, just to write it algebraically, it is for all values of y in y, these y's are in y, there exists x belonging to x. That means for each values of y, there should be some image, pre-image. So I have written down the meaning of these symbols. This is for all values of. This symbol is very common symbol, which means belongs to, and this symbol means there exists. So for all y's belong to y, there exists x belonging to x. So that is onto. Now, if a function is satisfying both the conditions, that function is known as bijective, 1, 1 and onto. So you see 1, 1 and onto. This type of function is also invertible function, but that is not useful from the point of view of your CBSE exam, which is scheduled for 9th of April. These type of functions are bijective functions. So they should satisfy these two conditions. Let us take an example. Check whether the function is 1, 1 or onto, bijective or not. The function goes from real number to real number. So there is mapping from real to real. In the next part, there is mapping from natural number to natural number. First, we'll focus on real to real. So let's see. Fx and the function given is fx equal to 2x. Now we'll check the condition for 1, 1. So what we're going to put? F of x1 is equal to f of x2. Simple condition. Our fx is 2x, so f of x1 will be 2x1 equal to 2x2. If you solve it, 2 gets cancelled, you have x1 equal to x2. So you see, by putting f of x1 equal to f of x2, we are getting x1 equal to x2. That means this function is 1, 1. Now, where x and y belongs to real numbers. Now for onto, fx can also be written as y, which is 2x. So x becomes y by 2. Now we'll see that does all values of y's are having x? That is the condition for onto, that for all values of y in y there should be x. Now y runs on real number, x is also real number. So if you put any real number and divide it by 2, you get a real number. The function is defined from real to real. So for all real values of y, you get real values of x. So this function, when it runs from real to real, is also onto. Now, since this function is 1, 1 as well as onto, it is bijective. Now let us look at the second part, when it runs from natural to natural. Here we go as usual, we are doing the second part. F of x is 2x, so f of x1 equal to f of x2. The solution will be similar for the 1, 1 part, solution will be similar. So 2x1 equal to 2x2, 2 gets cancelled, x1 equal to x2. So you see, since it is satisfying, it is still satisfying this condition, it is 1, 1 for natural number to natural number. It is 1, 1. Now coming to onto part, y is equal to 2x, x equal to y by 2. Imagine this function runs from natural to natural. So if you choose y equal to 1, x becomes 1 by 2. Is 1 by 2 a natural number? Answer is no. Since our function in this case, in the second part of the question, runs from natural to natural, and if I choose y to be a natural number, which is 1, for all odd 1, 3, 5, 7, x is not a natural number, that is fractional. So this function is not onto, because there is no pre-image. There is no pre-image for 1, because it should be mapped to 1 by 2. No pre-image for 3, that is it should be mapped to 3 by 2. So for odd values of y, there is no pre-image, because there is no natural number which is fractional, right? Fractions are not natural number. So for function running from n to n, mapping from n to n, natural to natural, it is not bijective. It's not onto and hence not bijective. So you see, a function, same function, when it is mapping from real to real is bijective, but when it is mapping from natural to natural, it is not. So it is extremely important while solving problems based on functions, to see where the function is mapping from. The first thing which one should be noting or should be careful of is where the function is mapping. from natural to natural, from real to real, fractional to fractional, integer to integer, that matters the most. So the next kind of problem that one gets from a function is to find its domain and range. How to find domain and range? So what is domain of a function? Domain is valid values of x and range is valid values of y. Like y which belongs to y. Or x which is belonging to x. Now we can find out through an example how and what we mean by valid values of x and y, or by what we mean by domain and range. So you see, let us take an example. Fx equal to square root of 9 minus x square. We need to find its domain and range. So domain should be the valid values of x. Now these are real functions. Real functions means mapping is from a real number to real number. That is, you are allowed to pick all possible values of x and y. Now with given condition, we need to tweak our values of x and y to give the real values of x and y. That is domain and range. So let us find out. You see, the square root function, for this function to be real, this square root function cannot be the argument of this square root cannot be negative. So you see, 9 minus x square should be greater than or equal to 0. That means 9 should be greater than or equal to x square. You may invert it, x square should be less than or equal to 9. So which gives x must belong to minus 3 to 3. So your value, so domain of, therefore you may write domain of f is minus 3 to 3. Now we want to find out range of this function. So what is range? What do we mean by range? Range is what is the minimum value the function may take and what is the maximum value. So it is the list of all the values, the minimum and the maximum values a function can attain. So the range for this function, if you look at this function, the minimum value that this function may take is 0 because square root will always give you positive values, right? Now x square is always positive, so if you take x equal to 3 or minus 3, this will become 0. So the minimum value is 0. Maximum value, what is maximum value? Since something is getting subtracted from 9, if you take it positive, like if you're taking any value other than 0, then something will get subtracted. Its value will always be less than 9, right? But if one chooses 0, x equal to 0, the maximum value will be square root of 9, which is 3. So we need to check by putting the domain values inside the function to find the maximum and minimum value of fx. So range of f will be 0 to 3. Minimum value the function can attain is 0 and maximum will be 3. Let us take another example. For the real valued function fx equal to square root of, let us take log of square root of 16 minus x square. Find its domain and range. Let's see, fx is log of 16 minus x square. Let's see, if you recall, the logarithm function looks like this: log x. So there is no logarithm is not defined for negative values of x or negative values of its argument. So when this x becomes 0, it attains minus infinite value. And when x attains 1, logarithm is 0. So when argument is between 0 and 1, the logarithm attains negative values. Now you see 16 minus x square, because it is in logarithm, should be only greater than 0, because the argument of log cannot be 0, right? Because 0 will lead you to negative infinity. So x square should be less than 16, so x must lie between minus 4 and 4. You see, open bracket of minus 4 and 4. Open bracket means the end values are excluded. So you have all the possible values of x excluding minus 4 and 4. Therefore, domain of f is minus 4 to 4. Now what is range of f? Range means what values the function can take. What is minimum value and what is maximum value. So you see, the maximum value the function may take is when x becomes 0. So when x becomes 0, it will be log of 16. That means log of 4. So the maximum value the function can take is log of 4, which is log of 4 is also 2 log 2. So we can change it to, because log of 4 is log of 2 square, which will be 2 log 2. So it will be 2 log 2, which is the maximum value, and close bracket, because it is attaining log 4 or 2 log 2. The minimum value, you see, you can choose x such that 16 minus x square lies between 0 and 1. You may choose x to be 3.99999999, and then this difference will be 0.00 something, which will be very small positive value, and very small positive value will lead you to negative infinity. So the its minimum value will be negative infinity. So that's how you find out domain and range. So conceptually, that's all we have from relations and functions, guys. We solved very simple examples on relations and functions apart from covering the basic concepts. We'll be doing the same for the full syllabus, so stay tuned. And we'll be back with very, very important questions which may turn up in your board exam, as it is. They'll be very highly likely. So let's meet in the next video, guys. Till then, take care. Bye.